All right. This section is called parallel and perpendicular lines. It's going to be pretty short. We're going to talk about the conditions, the slope conditions for parallel and perpendicular lines. We'll look at some examples. I'll tell you what kind of problem you can expect to see on the test. All right, so first of all, parallel lines run right alongside each other. They never intersect. So this is an example of what two parallel lines might look like. The two lines that are parallel, they run right alongside each other. They never intersect. They never cross. Perpendicular lines cross at a 90-degree angle. So for example, there's something like this. They would cross at a 90-degree angle here. And because of the way that these lines look, you could probably figure out that their slopes are related. So that's the sort of the definition of parallel and perpendicular lines that I'll tell you about, how their slopes are related. We're going to talk about parallel lines first because they're the easiest. I'll underline the important parts here. First of all, anytime you're talking about parallel and perpendicular lines, these have to be non-vertical lines. Two non-vertical lines that are parallel have equal slopes, so they have the same slope. So two lines that are parallel have the same slope. I'll let you guys write that down, and then I'll talk about why they specify non-vertical. All right, so if you have two vertical lines, if you remember from, I want to say this was the last section we covered together, these technically are running parallel to each other, but their slopes are undefined. The vertical lines have undefined slopes. That may have been in the video you were supposed to watch on your own. But vertical lines have undefined slopes, and that's why they specify that they have to be non-vertical, because you can't really say that two slopes that are undefined are equal. Something that's undefined is not equal to anything. So that's why they specify that they're talking about non-vertical lines. All right, so let's look at an example with parallel lines. These examples are a little bit challenging, but I'm going to show you a sort of an outline for how you can do them the same way every time, and that makes it a little bit easier. All right, so this is number one. I'll give you a second to write this down. You'll see two types of questions that look exactly like this in the homework. One of them will say parallel and one will say perpendicular. That's why they bold that parallel there. I'll turn down the lights a little bit so you can see that better. All right, so find the equation of the line which passes through the point -7, 3, and is parallel to the given line. Then it says express your answer in slope-intercept form. That's just a fancy way of saying getting y by itself. So this part here just means get y by itself. That's what that line means. And then simplify your answer. So we don't want to have any like terms that can be combined left in our answer. I just remembered as I was walking back through here, you can also get bonus points by going to Rebecca's SI sessions. So if you go to 3 of Rebecca's sessions, I'll give you 3 bonus points on the test. So let's see, I think it's a 5 points for the practice test, 3 points for the computer ready quiz, 3 points for SI, that's 11. And there's a bonus question on the test that's worth like 4 points. So that's like 15 bonus points you could get for the test. All right, so let me show you, oh, and let me read the equation to you. Oops, sorry. It says 6y minus 11 equals negative 2 times 2 minus x. All right, so right now it's all over the place. It's really messy. The way that I like to outline these problems is to refer to them as the old line. That's the one we're given. So we have an old line and we have a new line that we're trying to find. So we have an old line that we're given, and we have a new line that we're trying to find. Sorry, I'm trying to work. Now I'm going to write down my old line here on the left. My old line is what I'm given here. So that's 6y minus 11 equals negative 2 times 2 minus x. And then over on the right side, I'm going to write down what do I know about my new line. So the first thing they tell me is that it passes through the point negative 7, 3. So let's write that down. Passes through negative 7, 3. And I also know that it's parallel to the old line. So it's parallel to the old line. And that means they have the same slope. All right, so now I've written down everything that I know. In order for me to find the new line, there's a couple of ways I could do it. If I knew 2 points, I could find it that way. If I knew the slope and the intercept, I could find it that way. Or if I knew the point and a slope, or I said that backwards. If I knew a point and the slope. So I know a point, and I know that the slope is the same as the old line. So I can go to my old line, figure out what the slope is, and then just move it over here. So let's find the slope of this line. That's what I'm trying to do here, find the slope. So to find the slope, we want to put this in slope-intercept form, so get y by itself. The first thing I would do would be to multiply through by negative 2, and then I would start working on this other side. Right, so that's going to be, just going to bring down that left side, 6y minus 11. That would be negative 4 plus 2x. All right, then move the 11 over, combine it with its like term. So that would be 6y equals 7 plus 2x. Divide by 6. I like to divide everything separately. So divide each piece by 6. Just makes it easier when you go to find the slope if you have everything separated. All right, so we have y equals 7 over 6 plus, what is 2 over 6 reduced to? 1/3 x. Now this is almost in slope-intercept form. Remember, slope-intercept form looks like y equals mx plus b. And you may cannot go ahead and identify what the slope is from here. But if you prefer to see it in the opposite order, you could just rewrite this and say that would be y equals 1/3 x plus 7/6. So just rearranging, switching the order there. The slope is the number that's attached to x. So what's the slope here? 1/3, yes. So m is 1/3. Bring that up. Use it for our new line. All right, so our new line is parallel to that old line, which means they have the same slope. So that means my slope here is also going to be 1/3. And now I can just use point slope form to find the equation of the line. Again, I'm using point slope form because I know a point and slope. This is point slope form. Y minus y1 equals m times x minus x1. This is something you're going to want to have on your index card if you don't have it memorized. Go ahead and label your point. This is x1, y1. And now we'll just plug in everything we know. Go ahead and extend the page so I don't run out of room. All right, so that's going to be y minus y1 is 3 equals m is 1/3 times x minus x1, so it's x minus -7. Be careful there with the double negative. All right, so go ahead and change that double negative to a positive. Multiply through by 1/3. I'm going to multiply through by 1/3, and then I'll move that 3 over at the end. So that's 1/3 x plus, here you just multiply the numerator times the number. 1 times 7 is 7. Denominator stays the same. You could do that in your calculator though, if you feel more comfortable that way. All right, move that 3 over, combine it with the like term. Get y equals 1/3 x plus 16 over 3. Oh yeah, I wanted to show you on the calculator how I was doing that. Just in case. I'll switch over to the document camera and just show you how to, just remind you of how to convert the decimal to a fraction. All right. So we have 7/3. I'm just using that little divide by button right there, 7/3 plus 3. It gives me a decimal. If you want to convert that to a fraction, you just hit the math button, which is right under the alpha button. So hit math, and it's the first option, which has a little arrow. It says frac. That means convert to a fraction. So convert, it says take the answer, convert it to a fraction, 16/3. All right. And we're done. The answer is like intercept form, we've got y by itself. So we're done. So let me just remind you of what we did. Like I said, I like to separate these into old line and a new line. That way you kind of have a pattern. You're doing the same way every time. You write down what your old line is, and then write down what you know about your new line. You can shorten this however you want. You don't have to do it exactly like I'm doing it. Some people will just do it all in a straight line. They'll take the old line, find the slope, go down here and do the point slope form. But I think this keeps it nice and easy. All right, so write down what you know about the new line. Figure out what the slope is. based on your old lines, and then use point slope form to figure out the equation. All right. So like I said, you'll have a problem like this on the homework where they're parallel and one where they're perpendicular. We'll do one like that at the very end of class. But next, let's talk about perpendicular lines. Again, they specify that these are two non-vertical lines. Two non-vertical lines that are perpendicular have opposite reciprocal slopes. And we'll talk about down here what does opposite reciprocal mean. Or you could call this negative reciprocal. All right, so remember, if your lines are perpendicular, they cross at a 90-degree angle. If they're parallel, they never cross. They run right alongside each other. All right, so let's talk about opposite reciprocal. Let's say that we had two lines. We'll just call this like the first line and the second line. Let's say the first line had a slope of 1/2. The opposite reciprocal of that means, first of all, you change the sign to the opposite of whatever it currently is. This is positive, you make it negative. And then you take the reciprocal of this number. What would be the reciprocal of the number 2? 2, or just 2 over 1, whichever one you want to do. And then you could reduce that to negative 2. Right, so that's one example of an opposite reciprocal. Let's say we had n equals -4. What would be the opposite reciprocal of -4? Whatever 4 positive 1. So again, just pretend like this is over 1. Change the sign. So the first one was negative, second one's positive. Then flip it. That becomes 1/4. All right, so the next one I'm going to show you, the next problem, is what you'll see on the test. There'll be a problem just like this on the test. Just put a star beside it, because we know it's going to be on the test. I picked this one for the test because I thought it kind of lended itself to a multiple choice question. It just says, given the following equations, determine if the lines are parallel, perpendicular, or neither. So that'll be like your answer choices. A, B, and C, parallel, be A, perpendicular, be B, C will be neither. Now, most lines are not parallel or perpendicular. So it's kind of a special case when they are parallel or perpendicular. All right, so we have the first line is 4x minus 5y over 2 equals x plus 1. And then we have negative 4y minus 5x equals 5x plus 1. All right, so we're just going to look at each of those lines separately. We'll figure out what the slope is for each of the lines. Then we'll compare the slopes and determine if they're parallel, perpendicular, or neither. So just draw a little line down the middle. Write the first line over here. And then the second line over here. All right, so to find the slope, I need to get y by itself. I do not care about the y-intercept here. The y-intercept is of no consequence to us in this problem. We only need to know the slopes. All right, so that's what we're doing here on both sides. Find the slope. We're just going to find the slope. So we need to get y by itself. The first thing that's standing in our way is over here, this big fraction. So I'm going to start by multiplying both sides by the denominator. Notice I'm putting parentheses around it. That's going to tell my brain that I need to distribute. Over here, it's going to just cancel out. The 2 in the numerator cancels with the 2 in the denominator. So you're just left with 4x minus 5y on the left equals, multiply 3 by 2 over here. That'd be 2x plus 2. Right now, it looks much better. We just need to get y by itself, so let's move that 4x over and then divide by negative 5. Negative 2x plus 2. Divide each piece by negative 5. Right, so y equals, what's that reduce or simplify to? Yeah, just 2 over 5. X. I don't even care about this y-intercept. If you just want to ignore it, that's fine. All I care about was what that slope was, which was 2 over 5. Right, so the slope is the number attached to x. On the right-hand side, that looks much better. No fractions to worry about, so we just need to get y by itself. All right, so I'm going to start getting y by itself. I want you to do the same, and then we'll make sure that we have the same equation at the end. If you don't want to reduce this fraction in your head, you're welcome to do it on your calculator. Totally your preference. What's the slope of our new, or excuse me, of our second line? Yeah, negative 5 over 2. All right, so now we found both of the slopes. We just need to compare them. Are these the same? Are they opposite reciprocals or neither? Yeah, they are opposite reciprocals. 2 over 5 is the opposite reciprocal of negative 5 over 2. These are opposite reciprocals, which means they are what? Yeah, perpendicular. All right. Any questions about what we did here? All right, so definitely expect to see this on the test. I think it's a little bit easier than these other types of problems. Hopefully this one won't be an issue. All right, let's look at our last problem, which is very similar to the first one we did today, just with perpendicular instead of parallel. So almost the same exact directions. Find the equation of the line, which passes through the point 6,4 this time, and is perpendicular to the given line. Express your answer in slope-intercept form and simplify. So I'm going to start this one exactly the same. I'm going to use that same little outline, like old line and new line. You will not see these on the test, but you will see them on the homework. All right, so I'm going to draw my little outline. I'm going to write what I know. Old line, new line. I'm going to go ahead and write my old line down. And I'm going to write down what I know about my new line, that it passes through the point 6, 4, and it's perpendicular to the old line, which means the slopes are opposite reciprocals. So now everything that I know is written down. Now I'm going to start by finding the slope of my old line, which means I got to get y by itself. What would y'all do to that equation over there to get y by itself? What would you do first? Subtract the what? It doesn't matter which one you do first. The y, yeah. I would move that. Go ahead and move this guy right here over. But if you move that 7x over first, it's not going to mess you up. Right, so we have 7x plus 2y equals -2. And go ahead and move the 7x over, trying to get y by itself. I'm going to put it in the front so that it looks like my slope intercept form. So I'm going to write the part with x first and then the constant. That cancels. Got 2y equals -7x minus 2. Divide everything by 2. Remember, right now, I do not care about that y-intercept. I only need to know the slope. That's my whole goal for doing this. So what's the slope here? -7 over 2. Okay, so someone got confused at this point yesterday. They wanted to plug in the same slope. Again, why do we not come over here and use n equals 7 over 2, sorry, -7 over 2 as the slope? Yeah, it has to be the opposite reciprocal. If they're parallel, it's the same slope. If they're perpendicular, it's opposite reciprocal slope. So what should my slope here be? Yeah, 2 over 7. So change the sign, it's positive, flip this fraction, so 2 over 7. All right, now I'm going to do point slope form, which is y minus y1 equals n times x minus x1. Go up here and label your point. I gotta extend the page. All right, then just plug in what you know. All right, so that's y minus 4 equals n is 2 over 7. X minus x1 equals 6. I'm not done yet because remember they said they want it in slope intercept form and they want it simplified. So I like to just go ahead and multiply through over here before I move anything over. So I'm going to do that. That would be 2 over 7x minus, remember multiply the number. the numerator times the number, so that would be 12 over 7. Add 4. So that's 2 over 7x. I did not do that in my head, just remember it. And that's it, you're done. So the whole goal here is to find the new equation or the new line. So we're done. All right, so I would say that these are the more challenging problems that you'll find on this homework. So like I said, the one that you can expect to see on the test is like number 2, where you're just given 2 lines and you're asked to determine if they're parallel, perpendicular, or neither. All right, so before you guys leave, I'm just going to run through